All right, in this podcast, we're talking about, it starts off with sets of vectors, and then, let's get real mathy and confuse ourselves. But what it's really talking about more than anything is arrays, okay? And then strings, lists, things like that show up. I want to just explain the notation here, a little bit of mathy notation, right? So this set of, they call it kind of x to the n, right? And what this really means is that for this set of x1 to xn, x sub 1 to x sub n, where every one of those values for I, x sub I is in the big set of x. Okay, it's sort of a way of kind of saying I'm going to pull values from that set of x, like integers or real numbers or characters or whatever. And then they're going to kind of have an order, and the order is going to matter, and they're kind of be indexable. What I really want to say about arbitrary size vectors, other than this, I think this notation is intensely not helpful, is just that in the fixed size vector, I know how big it is, and in an arbitrary size vector, I don't. Okay, and we get a lot of interesting implications when we have, certain kinds of languages that have, kind of lazy evaluation. I can do conceptual manipulation, and I don't actually have to tell you what the millionth index into an array is until you ask for it, and until then I can just symbolically, conceptually hang on to it, and so you get into these funny dynamics when you start talking about those kinds of factors, right? And the traditional array is one that we know how big that array is, right? We kind of tend to define those things, right? So the types that we deal with related to the mathematical concept of a vector are arrays, strings, and lists, like we said, and they're a little bit like tuples, right? But with a handful of variations. The biggest one of which is the notion of an index in, and I realize that that's a little bit kind of munged together when you look at something like the ML feature of pound one, pound two, which is an index, into a tuple, and therefore the tuple can be viewed as a list, right, of sorts, right, a list of two things. So, the lines get really fuzzy all of a sudden. Also, when we talk about lists, does that include linked lists, which is a fairly complex structure when you really get down to it, right? And all the pointer manipulation and things you have to do when you're doing that, from scratch in a language that doesn't just give you, sort of list objects, list classes and things like that. So again, so much variety. But anyway, the notion of an index value and the notion of whether the array size is fixed at compile time are two interesting ideas. So, okay, relative to index values, Java, C, C++. In all of these, the first element is A sub 0, and and the indexes always go from 0, etc. In C and C++, and my actual experience with Java is very limited, so I can't speak to it. But in C and C++, you get things like strings, which give you sort of null termination, right? So you've got an allocated amount of space, but you've also got like a dynamic range within that by the value that sits there. That's an interesting idea, right? Ordinarily, though, there's only so much room allocated. And in those kinds of languages, you start to get into questions of how carefully are you going to control that at runtime, right? Can I just declare 80 characters in a string or in an array, right? And then just get my index going, and then just start writing that string, and then pretty soon I blow out of the 80, and I'm just writing random memory. That's a classic C or C++ bug. Because of just the flexibility provided in the language and the fact that it's not going to stop you. But in Pascal, when you say I want an array, well, let's jump over. Here's an example. If I want an array, it's not a great example because it's indexed by letters. Okay, so I can do that. But even if I set up an array of 80 characters in Pascal, I can't overrun it. I mean, I'll get, I don't even remember if it's a syntax error or a compile time error or a runtime error, but I can't do it. It'll create bounds and protect me, whereas in C, it's not going to protect me. In that case, back to C. Again, we can choose the index, the starting index. Classically in Pascal, the index is started at 1 kind of by default. I don't know why that is. And you can also in Pascal declare like subranges and a bunch of kind of interesting ideas, right? Anyway, but there's an example of an array in Pascal, and right. So in this case, just to kind of walk you through the syntactic stuff here, I define a letter count as a type, which is an array from A to Z of integers, and so my index is A, and it goes up to Z. The type of each element is an index. Sorry, an integer, and and then I've got, I declare a variable, which I call counts, and this is backwards from kind of C, C++, Java, right? Here I give you the variable name, then I tell you what type it is. It doesn't matter, right? That's just the way this thing works. And then I start shoving values in. I put a 1 in count sub character A. It's a little funky, but anyway, that's all valuable and viable in Pascal. And then, just various issues, right, relating to vectors and arrays and these kinds of things. It's actually a really, really complex topic. We could spend a lot of time on. But here's some questions to just kind of think about, what index values are permitted, right? Typically in C, we think of C, C++, Java, we think of indexes into an array as being integers starting at 0. We don't get a lot of weird power to do the other thing, right? And you could be thinking about, why would you want that? That's a good exam question. Why would Pascal want to allow you to go indexing from A to Z? Isn't that funky? Why give you that power? And then take it away, in other contexts. Do I set the size of the array at compile time? And do I make that part of the static type? What are the operations I can do, right? What can I add to arrays? What does that even mean? Can I, do I add kind of like a byte-wise addition? Can I concatenate arrays if they're strings, right? That whole notion of what operations I'm going to permit. Multidimensionality, right? I mean, you kind of have that in ML if you think about lists of tuples, lists of lists. Well, in C and C++, you've got the notion of multidimensional arrays, right? An array of an array. And you can do certain kinds of stuff with that. And then, how do you index that? What's the, which one's which, right? I've done code before in C where I didn't even know what the index was because I just wasn't a good enough programmer at the time. And then, in retrospect, I had it all backwards, but it turns out as long as you're consistent, it doesn't matter. If you have a 2-dimensional array and you're swapping all your rows for all your columns, think about it for a second. It doesn't matter, depending, right, on a few factors. Is there a separate type for strings as opposed to just an array of characters? Right? And we're ignoring the whole object-oriented thing where they're just whole classes, like the string class, right? Is there a separate type for lists that are different, right? There's all these questions, and the truth is that there's as many answers to these questions as there are programming languages, just about. But again, be aware of that, and the kinds of things I might ask, I might pull from this list of interesting questions in talking about, kind of exam questions and stuff, primarily to just sort of create, to create some thinking, on your part about why you would do that, why you might do that. That's really the punchline on that sort of thing. So that's kind of it for vectors and arrays and strings and lists. We're not going to go any real deeper than that. And the next podcast, we're going to talk about unions.